I haven't been pumping out videos for this channel for the last couple of months because I've been doing some theater. I designed the lights for a local show, and that's kind of taken up all my time. And we had these very nice Behringer MS16 studio monitors in the lighting booth, and this is how the person running the light board can hear what's going on the stage, because the booth is usually sealed. And just before opening night, we went to turn this thing on. This is plugged in right now, and we pushed this button and the little red light didn't come on, and so there was no power to the speaker. So we had a big panic. I ran downstairs, and in a sound closet we had a box with another pair of these, and I opened it up and it said, there was a label on it that said, these don't work, there's no power, kaput. So apparently these things go out that way. It seems like a very nice speaker. I've never seen them before, but it's ported. It's real heavy, has mic inputs and tone controls, and it's looking at the date code here on the back, it's from 2004. So it seems like they go out by blowing up something in their power supply, or something happens that causes them to blow up in their power supply. So I said I'd take it home and try to fix it after the show, and now it is after the show. So gonna go in here and see if we can bring this thing back to life. We went down to Best Buy and got some $40 cheapo speakers, and they work fine for just listening to what the actors are saying. These are actually kind of overkill for the booth, because it seems like they're really sort of built for music. Anyway, down these long wells here are Phillips screwdrivers. I have a real long, nice German flat blade screwdriver that'll go down there, but I don't have a real nice Phillips. But I do have an old Craftsman. This is too big, but it does go down there and it does seem to grab. So I will unscrew these 4 screws, and then we'll see. There might be one under here too, and we'll get into this thing. I won't bother you with pulling the screws out here, but then we'll try to take this thing apart and see what's going on inside. All right, so these 5 screws are out from 1, 2, 3, 4, 5, the deep wells. Let's see if this thing will come apart, or if there's something under there. Seems like, oh, yep, it's splitting. Let me put these someplace safe. And what do we got? Got a big amplifier, a huge transformer. This thing's really nicely made. Amplifier, heat sink, board, and a ribbon cable to the front here. So let me see if I can get this apart. All right, we're in. Yeah, this thing is really nicely built. Big, heavy components, and everything's glued down for vibration or tied off, and it's sort of really well done. This ribbon cable to the tone controls and volume goes into a connector here, so you just unlatch that, and you can put this off to the side. And now we have the AC line goes right into this transformer. Which it doesn't say what its output is, but and then that comes to the board. So we want to see if power gets into here. And I'm looking at this shrink wrap down here, and it seems like perhaps there might be a fuse shrink wrapped into this line cord here. But I guess the easiest thing to do, if I can get access to the right side of this board, is just to probe around a little bit with the multimeter and see if we're getting any power out of this thing, and then we'll see about getting power into this thing. It's a shame to rip this thing apart because it's so nicely secured. Transformer, 400 milliamps, H250V, H250, 250 volts. I don't know what the H is. Looks like this unscrews from the transformer unscrews from the bottom, so maybe that's a way to get a little more access here. So let me see if I can loosen things up some more. So I pulled the 4 screws holding the transformer down. They had Loctite on them. It was very nice. And then these wires were all glued in. It looked like hot glue to me, so I took the hot air gun from the rework station and heated it, and it softened right up. And I was able to pull the input wiring up. And it really does look like there's a fuse hiding inside this shrink wrap. So I'm going to slice this open and see what's going on. Of course, that doesn't tell us why the fuse blew, but That's a first step just to see if power is getting into the transformer. If I look over here at this thing, it looks like it's a full wave rectifier and some big smoothing caps. And then I assume there's some big power transistors on the other side of this heatsink. But let's get into this and see if there really is a fuse hiding in here. I'm going to take the X-Acto and slice this open. It's really hard to cut. Use the X-Acto upside down, that worked better. And is there a fuse in there? What's in there? Or is it just some kind of big lug? Hope I'm not too in the way. So is this just kind of lug, or is it really a fuse? I've got the outer layer of shrink wrap off. And then there's another layer of shrink wrap. Yeah, is it just some binding post? That feels like a solder joint or something right there. All right, let's go to the next level. Yeah. And yes, it is a fuse. Confirmed. I don't know why you wouldn't just put a fuse holder in. Maybe some of you have some ideas in the comments. Is this a vibration thing or something? I can't see it all the way across, but it kind of looks okay. Visually, the filament in the fuse looks all right. Let's beep it. Yeah, the fuse beeps out okay. So that's the easy thing. I mean, we can see if we're getting current into this, maybe. I don't know. Can I connect to that? Hang on just a second. Let me goof around with this for a moment. So if I jam one of the multimeter probes into the crimped wire nut there and then touch the other part to the end of the fuse, it reads 120 volts. So power is getting through the fuse and into the transformer. So I really need more access to this thing, and this thing's kind of glued in here. So I'm going to take the heat gun again. Let me unplug this. And we'll just see if we can kind of loosen some things up here. This stuff melts right away. There we go. It just comes right up. A little ooey gooey, and a little warm too. But there we go. And I don't know what's holding this in. There's RCA jacks on the back, but I didn't see a screw back there. But maybe I should take another look because it does seem real solid. It seems more like just than glue holding it in. Let's get this too. There we go. Kind of. You know, it's pretty serviceable, all things considered, compared to like Apple products. Yeah, there's no screws underneath, and I can't see any screws in here. It just seems like the board is pressure fit in a slot on the side and a slot on the bottom, and that the whole unit should lift out. So I'm just going to brute force it a little bit and hope I don't mess anything up here. Although maybe these... trying to... because that's... That's flexing pretty good, but it does feel like the end where this heatsink power transformer thing is anchored down. Is there a screw down there? Not that I can see. I mean, there are these two screws here that are lock-tighted down. Is that a verb? But I hate to break those in case they're holding the tab of some power transistor or something on the other side. But you know, if it's a TO package, maybe that's not the case. Well, I'm out of other thoughts. This looks like it might have some heatsink compound on it. This one, these two. So maybe these two are holding the case of some power thing, and then these are the mounting stuff. Well, I'm out of stuff to try, so we'll pull these two screws and see if that makes it any easier. Should get a different screw container there. Okay, let's see. Did we make things worse or better? Oh, that's it. That's all it was. And so what do we have here? Got two power. Yep, just as we thought. That was heatsink compound on the tabs of these power transistor cases. So there's our amp, and now we can start to work on this thing a little more closely. Well, I've been probing around on these pins where the transformer output comes in, and I expect to see some kind of voltage on these, AC voltage, and I'm just getting some, you know, tiny millivolt, 2 millivolt, nothing currents. So either the transformer is not getting powered, or it's been blown open, or I'm probing in the wrong spot. So I think I will desolder these transformer leads. Yeah, and maybe disconnect the input side as well, so I can fully test out the transformer here. And maybe I'll find out I'm doing something stupid in the process. Of course, it's easier said than done to desolder these secondary leads, because they're all hot glued in here too. So let me see if I can kind of preemptively melt that away before I put the desoldering gun on here. Yeah. Actually, maybe I'll desolder it and then do that. So now we can beep out the secondary. Anyway, let's see what we got. And we're unplugged now, so that's good. Okay, so it seems like the coils are intact, and maybe something was pulling the rail down, you know. So let's plug this in again and see if we get some voltage on here. It's still not. It's still only half a volt, but I'm kind of thinking juice isn't getting into the transformer past that fuse. Maybe there's a mechanical disconnect on the way into the transformer. But let me take some more measurements with my alligator clip leads to make sure, and then we'll check the input side of this thing. I'm going to unplug it. Yeah, so I'm all alligator clipped up here, and we're still not getting any real voltage. Okay, we unplugged. Good. So there's not, there's no way to reuse these crimp-on wire nuts. I'm just going to cut this out. And I think I'll cut out this fuse size too. If I put it together, again, I'll put a fuse holder in or something. I don't know, but let's just see what we got here. Just cut both sides of that out. Let's strip this back. This is 22. Is that too much? I'm using the 22 wire slip, 22 AWG strippers. Let's see. How this primary side beeps out. If it does beep, you know, or what the resistance here is. It's open. Infinite resistance. We've blown the primary side of the transformer. Well, well, that's that. Yeah, it's open. So I'll see if I can get another one of these, but I'm not hopeful. Well, dang, that's kind of about the worst news possible. All right, well, we'll stop this for now till I can figure out where to go from here. So it's about 5 days later. Here's the transformer that came out of the speaker that has the open primary, and the question is what made the primary blow, and I don't know. We've had a lot of storms here in California. You probably heard about them on the news, and that's caused damage to other pieces of equipment in the theater. And so all I can think is, you know, there's some kind of power surge, you know, came through and blew this thing out. Obviously there was a fuse in line that's supposed to protect the windings in this thing, but it certainly didn't do its job. I've gone ahead and checked the board, the diodes on the board and whatnot, just to make sure there's not something obviously stupid on the secondary side. And it all looks all right. But, you know, with this design, the primary, anytime the speaker is plugged in, the primary is energized. So this thing's cooking all day, every day, 24 hours a day. It'd be nice if the switch broke the primary side instead of the secondary side, or as well as the secondary side. But I don't know whether that's the greatest design in the world or not. So my immediate question was, assuming I was just going to replace the transformer, was what size is this thing? And of course it's impossible to find out with the primary blown. You can't even guesstimate it using the resistance ratios of the windings. You know, you can kind of measure and go, well, this is, you know, a quarter of this, and therefore if I put this voltage in here, it'll be a quarter of that, you know, that kind of thing. Couldn't even do that. So I got on the Behringer website. I posted a thing on their forum, didn't get a response. I posted a thing on Reddit, didn't get a response. I sent email to 3 of their dealers because they refer their service work to their dealer network here on the West Coast. And the 3 West Coast, 2 of them didn't respond, and 1 in Nevada said, please be advised, we don't sell parts to people like you, which is odd because they're listed on the Behringer website as selling parts to people like me, but okay. So I went through all the Behringer service dealers, and I found the one that looked like it was the most sort of low-rent one-man band, and that was Audiolab in Georgia. They'd probably hate me characterizing them that way, but sent them an email, said, could you please tell me the voltage or give me a schematic, or do you have this part? And within an hour, and this is like past midnight in Georgia, I got a response from a fellow named Jerry there who sent me a little snippet of the schematic and said, this is an 18-volt transformer with a 9-volt center tap. So knowing that, then I could go on eBay and source this transformer here. They also sell the transformer, but they don't have it in stock for like 31 bucks. He was going to write China and see if it's still available. Obviously, they haven't had it for a long time. But once I knew the value of this thing, then I was good to go. So I got this on eBay for 30 bucks. Well, you know, 25 plus shipping and tax and everything. And I went with a 4 amp unit because the schematic showed 1.2 amps on each leg. I don't know whether that was 1.2 total or you know, or what do I say, 2.4 total. Couldn't, you know, tell. So I went with a 4 amp replacement unit, and now it's looking like that's a little big. The measurements seemed like it was going to fit really well, but the measurements of this don't actually match the ones in the listing. This is a little wider and a little bigger, so it may be that a 2 amp unit would have been fine and might have fit a little better. This is also a little taller, but that's not a problem. So, but then I thought, you know, better to go big than small. This thing will run cooler and everything will be fine. So now we've hooked it up. I've got 120 volts coming in from my isolation transformer into this, and then I soldered pigtails into the board here, and I've twisted them onto the transformer just to see if this will work, and it's turned on here. So if I hit that, you probably can hear it clicking. I don't know if you can see the little red lights on in this thing, and if I play some YouTube royalty-free music here, let's see. Yay. So the thing seems to be working fine, and then the question just becomes one of mechanically reassembling this thing and getting this transformer, you know, in a rigid position in there, especially since I can only easily screw one of these sides down. Maybe I'll be able to drill a hole through there. I may go ahead and order a 2 amp unit, which actually seems like that probably the size I should have used. Unfortunately, none of these transformer ads give you the actual volt amper stuff. They always just give you the output current. But anyway, this will certainly fix it if I can get it in there mechanically. So we'll see how that goes. I won't bother you with messing around with that. And maybe I'll order the smaller one if this turns out to be too much of a pain. So check back with me in just a second and we'll see what I wound up doing. And here is the quote-unquote finished unit that hopefully is working. I've been testing it as I've been putting it together. I did go ahead and order the 2 amp unit because it's a much better size, mostly physically but also electrically. The 4 amp unit, there was just no way to drill it to make the flange holes line up with the plastic holes in the base of this case. But the 2 amp unit, if you look at it in relation to the original transformer, is a much better size. They're much closer. And indeed, these flanges will go over the holes, even though I had to mount it diagonally. Not because the you know, this horizontal dimension, this top to bottom dimension wouldn't work, but when I mounted it that close, it banged into this pillar, so I wound up mounting it at a diagonal to kind of get it to fit in here. I was so happy when I took the original transformer out because I saw there were 2 holes directly underneath the transformer, and it looked like Behringer was making, you know, arrangements for the future. They could get an alternate supplier that provided a transformer like this with only 2 holes to mount it instead of 4, and then they could have mounted it straight up and down in the middle. But it turned out that those 2 holes I revealed were not threaded. They were only to provide strength to the other 4 holes. Anyway, so it's in here on the diagonal, so it clears the pillars, and I went a little crazy with the blue Loctite, which probably isn't as good as the original stuff in here, but it should be all right. This runs a little more than just close to 11 volts unloaded, so I'm sure when it's loaded it's about 9, and as I say, I've tested it and it's working. And I did go measure the current drawn by this on the secondary side with my min-max function on the meter, and it came out to, I forget, 900 milliamps. So a 2 amp transformer should be just perfect. It should just give it a, you know, twice as much headroom, twice as much as needed, and let this run nice and cool and give it some, you know, capacity for any any surging demands of the music. I did finally peel open the fuse, and it turned out to be an axial unit. It's a slow blow, I guess, for the inrush current to the transformer, even though it didn't do much. And it was still working, so I thought I'd reuse it, but I did want to put in a fuse holder, so I did. So I clipped the axial leads off of it. Never could figure out the value of it. It only says 1400 on it. So what is that, 1400 milliamps? Is that like 1.4 amps? Which is a lot for this, because on the AC side it only draws 100 or 200 milliamps. I measured that too. I can't remember what the number was, but that's kind of high, and maybe that's why it didn't blow when whatever damaged this thing damaged it. But so I went ahead and put it in a fuse holder, and then went crazy with the hot glue and glued everything in here. So I think that's about everything, and we're ready to screw this back together and see if it's going to work okay. Okay, we're all set up here. Here's a little more royalty-free music from a group called the 126ers on YouTube. Got kind of a Pink Floyd vibe, Alan Parsons Project vibe. It's pretty loud. These things are really moving air too. You can feel it coming out of the mic hole. Or it's blowing down. It's blowing down on my hands, moving quite a lot of air. Pretty loud, it's not distorting too much. Anyway, that's it. Thanks for hanging out with me. Like, subscribe, and we'll see you on the next one.